Good morning everyone. This is my final year project eye tracking interface for smart home control. Well, as we all know, human-computer interaction and Internet of Things are being developed rapidly, and the eye gazing tracking enable people to interact with computer directly with the mouse or keyboard, and IoT is commonly used for smart home control. The product aims to use an eye tracking technique to control devices at home for people who have physical problems. Let's talk about the development tool. I have used Python Arduino as a software. In hardware, I only use MacBook Air and ESP8266 as IoT part. I also use a lot of libraries in the Python and Arduino part. After talking the development tools, let's move on to the eye tracking part and IoT part. Firstly, I want to talk about the eye tracking part. We can control computer by our eyes. Here is the flow of human-computer interaction. Here the flow chart of it. Reading the image from the webcam, image processing, face detection, and eyes detection. And then calibration, point of gaze, and control the cursor. In the image processing part, getting the frame from camera and using threading to buffer frame can improve the FPS, frame per second throughput rate, and the separate thread to read and decode of video file film, freezing up the main thread to handle the actual image processing. After that, we're going to the face detection. We also use the hard features approach in the last semester, the regular features and the hard cascade classifier. Here is make the image to many windows. Then they search it. Is it a match for the frontal face? If yes, then further process. If no, then reject the sub-window. Then we can get the windows which is fit our face detection. After the face detection, we use the same method as eyes detection. We localize the face in the image, and a facial landmark detector have a 68 coordinate map the specific facial feature structure. Such as the left eye using the point 336. After we get all the coordinate and the information of our eyes, we can go to the calibration part. A calibration is needed to improve the accuracy of eyes gazing part. We can get 4 coordinates of our eyes center of eyes when we look at the 4 corners. Then use the coordinate to calculate the width and the height of the movable range of eyes. Here is the formula. The width of eyes is the formula up, left, and right. When we watch the up right and the up left, then up right minus up left xy coordinate over 2. Then we can get the width and the height of it. After it, the point of gazing, we can have the center of eyes by using the landmark detector features. The width of eyes 39 minus 36x. The height of eyes 38 minus 41 of y. Then we can have the ratio of it, the width test over the calibration of the width and the height. Then over 2 to get the average. The projection of x and projection of y can get it. When we have the projection of x and y, we can also control the cursor using the pipe input to let the eyes control the coordinate of cursor by the point of gazing of our eyes. Then, besides controlling the cursor, we also need to click it. We can look at the point for a few seconds to get the to click the information. For the IoT part, here is a prototype of a smart home. As we all know, our home have different parts such as toilet, kitchen, and living room. In different areas, we have different devices such as light, fan, and lamp. Therefore, it's just like a real home to let us to control the LED just like we control the devices. The Arduino part, we assign a web server to ESP8266 by using multicast DNS, and we need to program the ESP8266 at Arduino platform to connect Wi-Fi and set up DNS and develop a web page with ESP8266 as server. After that, connecting the light correctly and write down the GPIO of each devices of different location, and then using the import request module in Python to submit data to be processed to server so as to control the actuators on the Python. The importance of writing down the GPIO is that GPIO is the key information which we need to use request to send the information to turn on the device. However, after talking these two parts, we can move on to the limitation part. The limitation is that the detection of face and eyes will be affected by wearing glasses, and it may not be able to detect the pupil of a person who has small eyes, and it is difficult to control the cursor move up and down than left and right. Besides that, we need to have enough light intensity. If we are in the dimmer environment, it will be affected. To conclude, in eye tracking part, frame per second has been improved so as to perform the eye gazing part well. However, the eye gazing is the most difficult part since it involves many factors such as the angle and distance between users and camera. In IoT part, it has developed more complicated to control more devices. For example, they are separated into various areas of our home and devices. Actually, the application can control the devices as long as the accuracy of eye tracking part can be improved. My future planning is that using the infrared to implement the eye tracking part so as to get a better accuracy of eye tracking, because our eyes is in three dimension. However, my point of gazing part is using linear transformation. Therefore, the error of calculation is also exists. I hope infrared can infrared can help us to get the blind spot for us to have a reference point instead of using pupil to do it. That's all for my final year project. Thank you for listening.